So up first, we have Gerd Heber from the HDF Group, the head of the HDF Group, and he's going to talk about the most versatile container for sharing scientific and engineering data. Go ahead, Gerd.
Yes, thank you. And good morning, good afternoon, good evening, wherever you are. I'm Gerd Heber from the HDF Group, and today I'll be talking about HDF5 and its role as arguably the most versatile container for sharing scientific and engineering data, and how it's evolving to meet the challenges of a rapidly changing technological landscape. And I would like to thank Mike Folk and Stephen Varga for many discussions on this subject. And if there's anything in this presentation you appreciate, it's most likely due to one of their many suggestions. On the other hand, if there's anything that doesn't make sense, it's just me speaking. Okay, before we dive in, a huge thank you to Daisy and the organizing committee, our sponsors, and everyone who helped make this event possible. The core message today is that HDF5 is well positioned as a versatile and evolving container for structured scientific and engineering data. And I would like you to think of HDF5 as a public good, like streetlights. It's non-rivalrous and it's non-excludable. And its evolution is actually fascinatingly intertwined with another public good, namely language. And for me, these are truly exciting times if you are interested in data or in language or both. And on the other hand, public goods face unique challenges. They have always faced unique challenges. And I will end later with a call to action here for us to work on them together. Of course, facts and logic, and you got plenty of those already in today's program, are essential. But I think stories are what truly move us. So let me tell you a story. And the story begins in a turbulent time. Picture Vienna in Austria in 1900, around 1900, and it then was really a melting pot of intellect and change with figures like Niels Bohr, Ludwig Wittgenstein, and even Adolf Hitler present. Now, I must confess, I took author's license here. Niels Bohr wasn't actually there. But sometimes, yeah, we take license with dates and details. This era was marked by profound questions and the seeds of incredible progress and immense destruction. Amidst such potential for chaos, the need for structure, for ways to manage and understand the world becomes paramount. Now, where does something like HDF5 fit into this grand narrative of seeking order? Well, hold that thought for a moment. If you fast forward to Brussels 1934, there was a famous publication, Paul Otlay's Traité de Documentation, pardon my French, which was a truly visionary work about organizing world knowledge. And if you look at this diagram, it's remarkably prescient. Otley imagined a universal system connecting information, intelligence, and knowledge through what he called the bibliography or bibliography. He was essentially describing a precursor to the internet, to hyperlinked information and to structured data systems. Perhaps his vision of interconnected knowledge repositories. And that's exactly what HDF5, I believe, enables today: structured, hierarchical, interconnected scientific data. Now, if you fast forward a few decades, the world witnessed new scales of power and destruction. And you are in Hamburg today. In 1942, just about 5 miles or 8 kilometers from where you sit right now, this massive flag tower was built to last forever, in double quotes, and to withstand pretty much any attack. And I encourage you to go there. It's there. It looks a little different today, and maybe some people visiting it don't know anything about its history and so forth, but it's, yeah, it should make you pause and think. Meanwhile, at Los Alamos, scientists were developing weapons that would change everything. And the destructive power unleashed was immense. But what about constructive power, the power of information and the power of data? And that's where sort of Otley's diagram reappears, reminding us of the ongoing effort to structure and harness knowledge, even as the stakes and the complexities grow even higher. And in a way, the challenge of managing information is its own kind of powerful problem. Okay, against this backdrop of growing complexity in science and engineering, HDF 1.00 was released in November of 1998. And this was a significant step in providing a dedicated solution for managing complex data. For example, consider the inherent complexity it was designed to handle, as you can see in a figure from a seminal paper by Mark Miller and others: mesh types, coordinate systems, fields, various element and field types, storage conventions, decompositions, compressions, and more. HDF was designed to handle. And it provided a relatively simple structure with groups, data sets, and metadata to organize all of that. And once again, we see Otley's vision of structured knowledge, but now manifested in a concrete software solution designed for the scientific and engineering challenges of the, call it the late 20th century. And as a result, I believe HDF5 became a lingua franca, the bridge sort of between data producers and consumers, and between instruments and insights. And I for historical background, I recommend you listen to Mike Folk's three-part history of HDF and Mark Miller's presentation from X-Files to SAF, sets and fields, the early pedigree of HDF5. That was a presentation he gave, I believe, at the last HUG event at Ohio State University 2 years ago. And both are available on our YouTube channel, and I provided the link here. Now, it looks like, okay, so that completes our counterclockwise sweep in this picture. And it looks like the first 100 years following that class photo seem to be dominated by the forces unleashed by Bohr and Hitler. And while it was always there, language kind of remained in our blind spot. And of the three pupils highlighted, Wittgenstein is kind of the stillest voice. He realized that language is a tool that builds worlds or it breaks them, literally. And thinking about LLMs today, one of the key insights, I think, it's obviously not a quotation by Wittgenstein because he's no longer around, unfortunately. But people's language reflects their reality, whereas LLM's language reflects people's language. And this is something I think Wittgenstein could have said. So what we are seeing is a fundamental shift how we process and understand information. And yes, Niels Bohr gets a second helping, if you wish. There's also call it the second quantum revolution. And just as quantum mechanics revolutionized physics, quantum computing and AI are about to revolutionize how we handle data. And then the question becomes for HDF5, what's next for HDF5? How does HDF5, a system for structuring data that represents reality, interact with systems that model language about that reality? And I believe the fundamental components of HDF5 are still relevant, but the context clearly is expanding, and Otley's framework for understanding is challenged, but it's also enriched by these new paradigms. Now, this brings us to a crucial question for the future. Is HDF5 ready for X? And okay, what is this X? Well, broadly speaking, it's the next wave, the unknown challenges, the evolving landscape of data, AI, and scientific discovery, or open science, as people have come to call it. And we have, of course, the established power of HDF5 structures, the context of language and interpretation, but what does it really mean to be X-ready? And I'll give a few examples in a moment. The elements we've discussed, from Otley's classification to the complexities of modern science data and the underpinnings of language and reality, kind of all converge on this point. And clearly HDF5 needs to be adaptable and prepared for whatever these future requirements might be. And so, yeah, being X-ready means building inflexibility and adaptability, building in flexibility and adaptability from the ground up. And it means forging an HDF5 that can evolve without breaking backward compatibility, and being prepared for use cases we can't yet envision. We kind of don't know what's coming, but we need to be ready for it. Okay, let's get specific for a moment. Not that new, but one of the X factors is undoubtedly the cloud. So let's talk about cloud-ready HDF5, and there will be a lot more during this event. It isn't obviously just about putting files in the cloud. It is really about working with HDF5 data efficiently in cloud environments. And to me, cloud-ready HDF5 encompasses two complementary approaches. One, what we call cloud-optimized HDF5, or COH5, is basically restructuring HDF5 files for efficient partial reading from object stores. And secondly, our HDF5 scalable data service providing a REST API support for multi-reader, multi-writer, horizontal scaling, and fine-grained access control. If you wish, cloud-optimized HDF5 optimizes data at rest, whereas HSDS provides dynamic access and scaling. And I think together they put HDF5 on par with so-called cloud-native solutions, while maintaining sort of the strengths of our heritage. Another critical X, if you wish, is artificial intelligence and machine learning. And the question is, okay, how do we make HDF5 AI ML ready? And of course, AI ready HDF5 is not just about storing tensors. That's kind of a solved problem, except for maybe a few technical details. But looking at this table that is hyperlinked to a very interesting YouTube video I recommend you watch, looking at this table, and the question that might pop into your mind is, does going to the doctor make you sick? And at first glance and without any context, this is what this table seems to suggest. But I recommend you watch that YouTube video or think about it a little more. But it certainly illustrates the importance of context and metadata in AI workflows. And so AI-ready HDF5 means strategically designed containers that meet AI ML requirements. That includes GPU direct and things like that, about which I think we will hear a lot during this event, efficient access patterns for training, comprehensive metadata for reproducibility, data quality assurance, and seamless integration with frameworks like TensorFlow and PyTorch. And it's clearly about adhering to these FAIR principles, which are also crucial for AI workflows. So we are not just storing data, but we are preserving the context that makes data meaningful. Finally, I think we could go on with other examples, but I think beyond technical readiness, there is a crucial human element here, which I would call community-ready HDF5. And this is about the evolution of the HDF5 ecosystem itself, one that is structured, governed, developed to actively invite and enable valuable contributions from everyone, users, developers, and many other stakeholders. And this goes way beyond just being open source. It embodies the principles of openness, collaboration, transparency, and sustainability. And to me, this community-ready HDF5 would feature transparent governance, community-friendly infrastructure, an open and responsive development process, a roadmap shaped by community needs, support for ecosystem collaboration, accessible onboarding and educational resources, and be trustworthy and accountable. And I'm not saying that all of these are tasks where we start from zero. There's a lot of good work happening, and we've come a long way since 1998, but we still have quite a ways to go. And to me, this is frankly the challenge. It's about building this sustainable ecosystem that X-Ready HDF5 so that it can thrive for another 25 years and beyond. So I would say stay tuned for specific announcements in this space. And finally, the pen is mightier than a sword, as you can see in many places, including the Library of Congress. And as we saw earlier, language builds worlds or it breaks them. And LLMs change the way we manage data, but we must be actively engaged to get this right. And I think HDF5's ethos, I believe, is fundamentally exploratory and forward-looking. It's one of humility in the face of complex challenges and openness to new ideas and a readiness for adaptation. I think ultimately HDF5 is more than just a passive data container, and it strives to be an active mediator of scientific communication, and not a gatekeeper, but a guardian of knowledge preservation for the future. So thank you for being here today. If this little story, if this little HDF story made you think, then join us and the community writing the next chapters. Thank you. I'd be happy to answer any questions you might have.
I have
comments. Go ahead.
I have a question. So first of all, thank you for your talk, and I'm glad you said active mediator, because I have, maybe it's a discussion point for roundtable, but with my experience of 25 development with HDF5, we were reactive mediator. We were always late in delivering features that are needed by community. How do you think, and what needs to be done to change this, to be from reactive to be active, really active, to foresee the needs, and what community can do in turn to facilitate this? Thank you.
Yeah. Well, I think there are many things to do. I give you a few examples. And we know, of course, when we say users of HDF5, this is a wide spectrum that includes developers, that includes integrators, sometimes in industry, that includes users, small engineering firms, and so forth. So it's a tremendous spectrum. And I think this active needs incarnations or forms in all these different areas. So, for example, partnerships. We don't, I mean, do we have long-term relationships with some of our stakeholders? Absolutely. But we have not really gone of our way. I mean, how often have we bemoaned that, for example, an industry group has developed a new HDF5 based standards? They didn't talk to us, which you can speculate and think about why they wouldn't talk to us. But we found then that sometimes they make design decisions that we could have told them that weren't good decisions, or that would underutilize some of the capabilities, and or push certain capabilities to the limit if you scale this forward. So partnerships, definitely being involved, sitting at the table, reconnect with scientists. I think this is something something that not exactly faded into the background, but as we as HDF Group became more and more development focused, we have kind of lost touch, would be too strong a word, but we have disengaged from that conversation with users, listening to their needs, having not just a technical advisory board, but also having a scientific advisory board to get it sort of from the horse's mouth, so to speak, to understand these are the real needs, and then help us prioritize and help us when it comes time to make decisions. Or we talked about governance briefly. Ideally, many of these representatives would be directly engaged in some kind of advisory capacity to us, and could help influence and shape the roadmap and so forth. But yeah, maybe a good topic for a roundtable, so I can go on and on about this.
Thank you.
Anything else? Otherwise, yeah.
Any questions from here? I don't see.
I have a question.
Oh, go ahead.
Hi, Gerd. This is Mark Disoptical.
Hi, Mark.
I'm a bit curious about what you view as the future of, say, the website and the documentation. This has been, I think, undergone a few changes over the few years, and I'm just wondering where you feel that's headed. And
I think we are at a point where we have at least managed to put the code and large parts of the documentation on an equal footing, in the sense that no longer is documentation this thing that you can easily push aside, and it's in a completely different place and might have completely different people attached to it. So I think by using Doxygen, for example, and migrating not everything, but maybe 90+% of our documentation into Doxygen, it's now with the code. We treat docs like code, might be a more succinct way of putting it. But then, of course, have we done any quality improvements in doing so? No. It was really more of an to use a flippant expression, exercise in just taking existing content that in many cases was outdated and transplanted into this new environment. And yeah, that hasn't made the quality, other than perhaps the visual experience, in some cases better, in some cases worse, I would argue. But I think now is the time to regroup and think about, okay, let's think hard, prioritize where the quality is to a point, and not necessarily just improving quality of existing documentation, but also think about along the lines I just said. I want to onboard people easier, and that means right now, a comment we get frequently is, I would like to help, I would like to contribute to HDF5, but I don't know where to start. And so what that tells me is that, yeah, there might be documentation out there, but it's not suitable for those types of needs, for example. So I think, yeah, quality, gaps, identification, prioritizing all of that, that's sort of top of my list. Does that make...
Move on.
Sorry.
Let's move on. So let's thank the speaker again.
Yeah, thank you.